All right, this is the video for 7.5, solving rational equations. And the first thing that we want to do is make a big distinction between rational expressions versus rational equations. So in a rational expression, we just have an expression. There's nothing really to solve for. So for example, here I have the expression 2x plus 10 divided by 2x squared plus 9x minus 5. This is an expression. And we simplify expressions. So the answer is another equivalent expression. Has variables, coefficients, the whole deal, versus a rational equation. Now, it's easy to tell an equation versus an expression because the equation has an equal sign. So, equations have equal signs. And I know we've talked about this before, but it's important to go over this again to reinforce these ideas. And the answer is a collection of numerical values. X equals ... So when you're done, you have a numerical answer versus an expression. So let's take a look at some guidelines for solving rational equations. The guidelines for solving rational equations are as follows. They're real similar to section 7.4, complex rational expressions. There are two techniques for solving rational equations. That almost snuck by me there. Equations. One of those is obtaining a common denominator. So technique number one, obtaining a common denominator to solve a rational equation. And the guidelines are as follows. Step number one, factor each denominator on both sides of the equation and determine any and all values of x for which the equation is undefined. So that is, for what values is any expression in the equation undefined. So here we have, let's do this equal to 2 here. So for 2x plus 10 divided by 2x squared plus 9x minus 5 equal to 2, the first thing that we want to do is we want to factor all denominators involved. So first off, the right side is 2 over 1. Not a lot to do there. The left side, 2x plus 10. If we try a little bit of reverse foiling here, we have 2x and x. And let's see, a positive 5 will give me a middle term of 10 minus 1 more x will give me 9. That seems right. And so, no matter what, this is undefined if x equals 1/2 or negative 5. So this is very much like section 7.1, the intro to rational expressions. For what values is any rational expression in the equation undefined? And we're going to keep track of these later because we want to make sure that when we end up solving this equation, the answer is not one of these numbers because that wouldn't make any sense. So it's good to, right out of the gate, find the values of x that cannot possibly be a solution. Out of all possible values of x, these cannot be solutions. So we just keep those in the back of our mind, right? We don't want those numbers popping up because they'll make the left side undefined. Okay. Step 2. Determine the least common denominator for all terms in the equation. If needed, write any non-rational terms as a fraction over 1. Well, we kind of already did that, but here's our expression. Let me duplicate that. So when we talk about write any non-rational terms as a fraction over 1, we're specifically talking about 2 over 1 there, which was just a 2. And the LCD is a 2x minus 1 and an x plus 5. There's not a whole lot of work to do there. It's just simply the denominator of the term on the left side of the equation. Okay, we'll run into some more examples where that's maybe a little bit more difficult in the future, but let's keep going through our guidelines right now. Step number 3, multiply each term on both sides of the equation by the missing factors of the LCD to ensure all terms have the same denominator. All right, well, what are we talking about here? Not a whole lot of work to do here. And if we want, we could, I guess, do the following. Let's see. Let's erase some of this. The LCD is 2x minus 1, x plus 5, and I guess a factor of 1. So I could write 1 there, in which case this one already actually has the LCD, but we'll multiply top and bottom by 1, whereas the other side of the equation is going to need a factor of 2x minus 1, top and bottom, and a factor of x plus 5, top and bottom. Okay. So now we have the same denominator in all of our terms. Now, step number 4, combine all terms on a given side of the equation into a single term with the common denominator. That's actually done here. This is 2x plus 10 over 2x minus 1 times x plus 5 is equal to 2 times 2x minus 1 times x plus 5, all divided by 2x minus 1 times x plus 5. So, what do we have? Well, each side already consists of a single term. So, each side only has one term. So this step is skipped in this example. All right. Now, step number 5. Since the left side, this guy here, is equal to the right side, right? Equals right side. And both sides have the same denominator, 2x minus 1, x plus 5, 2x minus 1, x plus 5. Then both numerators must be equal. Write a new equation involving just the simplified numerators. So let's see. If that's the case, what I'm getting at here is we have these two expressions. They're equal to one another. They have the same denominators. And since I already know that they're equal, then these must be equal to, must be the same thing too. So we're going to set up a new equation, 2x plus 10. The numerator on the left is equal to 2 times 2x minus 1 times x plus 5. The numerator on the right. Cleaning this up, we're going to solve the resulting equation. That's our next step. Let's duplicate this. And we have, let's change colors here. 2x plus 10 is equal to 2 times, let's see, if we multiply this out, we have 2x minus 1 times x plus 5 is going to give us 2x squared plus 9x minus 5. And we have the following. Let's see. We can factor the left side as 2 times x plus 5 is equal to 2 times 2x squared plus 9x minus 5. We can cancel the common factor of 2. We'll divide both sides by 2. And we have x plus 5 is equal to 2x squared plus 9x minus 5. And so we will subtract 5 from both sides, and we'll subtract x from both sides, so negative x minus 5, negative x minus 5. On the left side we'll have 0. On the right side we'll have 2x squared plus 8x minus 10. Looks like there's another factor of 2 that we can pull out of there. Factoring this further, we have 0 is equal to 2 times x squared plus 4x minus 5. And if we factor that, we have 2 times x plus 5 times x minus 1 equals 0. So using the zero product property, either 2 equals 0, but that's nonsense, or x plus 5 equals 0, or x minus 1 equals 0, in which case x equals negative 5, or x equals positive 1. And so it looks like we have 2 answers, but there's one more step. Exclude any solutions corresponding to step 1. These are called extraneous solutions. So we have a term for something that's about to happen here. Let's talk about what that is. If we go back up to step 1, remember that we were going to factor each denominator and determine any and all values for which the equation is undefined. And those numbers were 1/2 and negative 5. And so we can't use 1/2 as an answer or negative 5 as an answer because they will make the denominator equal to 0, making this entire expression undefined. Well, it turns out that negative 5 was just one of those answers. So if x is equal to negative 5 or x is equal to 1, it turns out that we can't use this answer either. This is what's called an extraneous solution, since step 1 states x cannot equal negative 5. So, turns out there's only one answer here, and it's x equals 1. And those are the guidelines, the process that you want to follow for solving any and all rational equations using this technique.